$30 billion. I mean, just pause and let that number sink in for a second. It is an absolutely staggering figure, right? And it represents the sheer scale of Apple's recent manufacturing commitment to a single partner. We're not just talking about some routine supplier agreement here. This is a fundamental reshaping of the actual technology you are holding in your hand right now, and the massive servers powering the cloud above us.
Welcome to The Explainer. I am so pumped to dive into this with you today because we are looking at the literal silicon that is powering our AI future. We're going to unpack exactly how custom chips are driving both the next generation of wireless connectivity and the heavy artificial intelligence workloads of tomorrow. Seriously, it's this incredible story of cutting-edge engineering, massive capital, and really high-stakes strategy.
All right, here's our roadmap for today. We've got 1. The $30 billion deal. 2. Inside the Colorado facility. 3. Mastering wireless with FBR filters. 4. ASICs powering Apple Intelligence. And 5. The global AI chip race. Okay, let's dive right into this. We are kicking things off with Section 1, the $30 billion deal, a truly historic partnership between Apple and chipmaker Broadcom. So what does a $30 billion check actually buy you? Well, first off, it guarantees the production of more than 15 billion US-made chips. That secures Apple's supply chain all the way through 2031. It's actually Apple's largest single commitment under its American manufacturing program ever. But here is the really clever part. Beyond the silicon itself, this deal acts as a strategic multi-billion-dollar tariff shield. Because these chips are manufactured domestically here in the US, they just aren't subject to the import tariffs that have historically cost Apple hundreds of millions of dollars. It's a brilliant business maneuver, right? It totally insulates the company from all those unpredictable global supply chain variables. Moving on to Section 2, inside the Colorado facility. Let's ground the tech and see where this is actually happening. $1.5 billion. Out of that massive larger deal, this is the specific capital expenditure Broadcom is injecting directly into just one single facility located in Fort Collins, Colorado. So what's happening with that $1.5 billion? It's entirely dedicated to modernizing and scaling that Fort Collins plant. Broadcom is basically turning this location into an absolute powerhouse for advanced radio frequency production. Specifically, they're gearing up to manufacture something called FBR filters. And naturally, an investment of this size is creating and supporting hundreds of highly skilled American jobs. This Colorado facility is literally the physical anchor for this whole domestic manufacturing push. Which leads us to Section 3, Mastering Wireless, FBR filters. Let's zoom in a bit here. Okay, so what exactly is being built in Colorado? It's these film bulk acoustic resonator, or FBAR filters, and they are absolute microscopic marvels. Think of them like dedicated lane controllers on a super congested mega highway. When your phone is simultaneously pulling down 5G, connecting to Wi-Fi, and streaming audio to your Bluetooth headphones, these tiny filters are managing all that traffic so the different frequencies don't just crash into each other. Without FBAR filters, your device's wireless connectivity would literally collapse into a frustrating mess of interference. That is exactly why Apple relies so heavily on Broadcom. And this is not some brand new romance. Broadcom chips were actually inside the iPhone 3GS way back in 2009. Over the last 17 years, this relationship has evolved into the massive multi-billion-dollar extension through 2031 that we're seeing today. Apple locked in this highly specialized partner because the RF engineering involved here is just incredibly complex. Trying to go it alone and build this from scratch internally, it was simply too costly and way too risky even for a giant like Apple. All right, Section 4, ASICs powering Apple Intelligence. We're shifting gears from wireless connectivity to the cutting-edge backbone of AI. You are absolutely going to hear the term ASIC a lot over the next few years. It stands for Application-Specific Integrated Circuit. Look at it this way. If your standard general-purpose processor is like a multi-tool, capable of doing a bunch of different jobs pretty decently, an ASIC is a highly precise scalpel. It is engineered from the atomic level up to do exactly one single task flawlessly. And when you're dealing with the massive, heavy workloads required for artificial intelligence, you definitely don't want the multi-tool. You want the scalpel. It is just exponentially more efficient. Now, what's really interesting about this slide is how it highlights Apple's current AI bottleneck. Right now, their AI server setup uses repurposed Mac M series chips. Now, don't get me wrong, those are fantastic laptop chips, but running server-side AI inference on them, it's highly inefficient. It leads to a lot of underutilized server capacity. So the future solution is a custom ASIC, internally codenamed Baltra, and it's being built on TSMC's advanced 3-nanometer node. Broadcom is actually co-developing this purpose-built AI scalpel with Apple to solve this exact inefficiency problem. So here is the exact game plan Apple is executing to regain total control of its AI technology stack. Step 1, they co-develop the Baltra ASIC with Broadcom. Step 2, they manufacture it using TSMC's cutting-edge N3P process. And Step 3, they deploy these chips in 2027. Once Baltra is fully online, Apple can finally replace the Google Cloud infrastructure it currently licenses. That brings their AI processing entirely in-house, running at absolute peak efficiency.
Which brings us to our final act, Section 5. Let's zoom all the way out from that Baltra chip to the macro environment, the global AI chip race.
This table brilliantly illustrates the big picture of what Apple is actually doing here. It's like a giant puzzle, and piece by piece, they are methodically building an end-to-end U.S. silicon supply chain. Think about it. Processors designed in-house in the U.S., wireless tech over in Colorado, advanced packaging and logic foundries in Arizona, silicon wafers coming out of Texas. They are structurally insulating themselves from global supply shocks by localizing the most critical components of their entire tech stack. And that insulation? It's absolutely crucial right now, because the semiconductor market is currently navigating some major geopolitical variables and strict export controls, especially when you look at the dynamics between the US and China. Just looking at this objectively as supply chain variables, we can clearly see how these regulations are acting as massive, strategic business catalysts for companies all over the globe. For example, reports indicate that Chinese regulators might actually cap the import of NVIDIA's incredibly sought-after H200 AI chips at around 200,000 units. To put that cap into perspective for you, a single state-of-the-art modern AI data center can require upwards of 400,000 chips. So the constrained supply we are talking about here is just incredibly stark. Furthermore, Beijing is strictly managing exactly how those imported chips are utilized. They are reserving them exclusively for AI model training. But for the other side of the AI coin, the inference workloads, like what happens when you actually ask an AI a question, authorities are mandating that companies prioritize domestically developed silicon. It's a totally fascinating bifurcated regulatory model. And you better believe this structural fragmentation is having immediate impacts on the market. Because of these constraints and mandates, Chinese AI pioneers like DeepSeek are aggressively moving to build their own in-house inference chips. They reportedly just raised a massive $7 billion funding round to do exactly that. Just like Apple is building Baltra to control its own stack, companies worldwide are realizing that relying entirely on external monopolies for AI computing is a bottleneck they simply cannot afford. We have covered some incredible ground today, from a $30 billion deal for wireless filters in Colorado to the custom ASICs defining the very future of cloud computing. I want to leave you with this final thought to ponder. As companies across the globe pour billions and billions into developing their own in-house custom silicon, will this permanent macroeconomic shift completely reshape the global balance of tech power? It is a fascinating question, and for sure one we'll be watching unfold over the next decade. Thank you so much for joining me on this explainer today. Keep learning, and I'll see you next time.